All right, so first off, I'm gonna go ahead and I want to review a little what we talked about on Monday because it was pretty dense with all the spreadsheet work that we're doing. Okay, so this is what we kind of spent time working on a lot of Monday, right? There's a lot of information there. And really, it was about just learning a couple key techniques, including sensitivity analysis and scenario analysis. But part of the reason for me wanting to kind of build that spreadsheet with you is because to do sensitivity analysis and scenario analysis, you kind of need to build a financial model that has links in it so that when you change one of your assumptions, then the whole spreadsheet automatically changes because of those links, and your MPV is automatically calculated for you. So like if you just want to change the sales number in year one, you do that, but then everything's linked in the spreadsheet and boom, all the changes follow right through and your whole MPV is calculated for you. So that makes all this what if analysis with sensitivity analysis and scenario analysis, it makes it easy to do. And you don't really have any excuses for not doing it then because the spreadsheet model is built in such a way that it's easy to update. And so by going through there and building it with you, my goal was to help you guys kind of learn more and more about Excel so that you're comfortable with, either if you had to create something yourself or very often companies will give you a spreadsheet that's already kind of filled out that people have been using, then you would just need to update the existing spreadsheet. So let's take a look at this. So we built this spreadsheet, right? And the key, the first step was to identify our key assumptions in our model, right? Because we identified these right here. These were our key assumptions. We identified the investment that we had to make up front, then the initial year of sales, cost of goods sold, SG&A, and working capital, right? And then what we did is we kind of came up with our expected numbers for each of those. What was the forecast that we expected for each of those assumptions? We called that those expected numbers. Now, this is where sensitivity analysis comes in. Then we decide kind of a worst case and best case for each of those assumptions. And that worst case and best case, I don't have an exact formula for where to come up with those numbers, but it's kind of based on experience, and it's going to be based on interviewing and talking to people and finding out, people who have the experience at, building buildings or certain investments that you want to make. What are the bad things that could happen, and what would the resulting, cost or revenue be under those bad situations or really good situations? So you would do that for cost of goods sold, SG&A, working capital. You'd have to probably interview people and find out, what's the worst that could happen? What's the worst that we could expect? And so it is a little bit of kind of like this judging the wind, gut feel. But that's kind of how it is. So once we have these assumptions built out, right, then we go ahead and calculate MPV. And first we do it using these expected numbers right here. And that's the MPV you see over here. So this is the table where we record all the NPVs that we're going to calculate when we do the sensitivity analysis. So, for example, let's look at investment in year zero. We looked at a worst case. A worst case investment means we're going to have to invest a lot more than we anticipated, right? And so in this example, we said $130,000. So then what we did is we only changed investment, just one change at a time, and then we calculated the whole new MPV. So like since the spreadsheet's already linked, I'm going to change this to 130,000 right here because that's where the spreadsheet link goes to. And we see, what do we see? 35,000 NPV. That doesn't look right. Well, that's what we did yesterday. But the point is, and we change each number individually, and then we record the NPV over here. So with a worst case investment of 130,000, we said the NPV was then 12,583. But with a best case of an investment of 90,000, we said the NPV was 52,583. So once we do that for our different assumptions, changing one variable at a time and recalculating the NPV, and then finally recording that NPV in the table, we're left with this table of all these NPV values, net present value. Now here's where the analysis comes in. Now we decide where the risk is. And the risk is where we have the most negative NPVs. And so for us in this case, we have right here, and it's under sales in year one. So now that you understand where the risk is, where the NPV is most sensitive to changes in assumptions, that's when you kind of do the analysis and you ask the questions, well, what can we do to mitigate or reduce this risk? And so maybe, I don't know, just for example, maybe people would say, hey, let's do some advertising before the business opens to help build up demand, to help increase sales. We're really not sure what it's going to be like because we haven't done any surveys. Well, maybe they should do some surveys to get a better handle on what the expected sales will be. So this doesn't answer those questions, but it lets you know where the risk is, and then you have to decide if you want to do anything about that risk. So that's what's nice about sensitivity analysis. And the neat thing is, if you're in a situation where you have to do something like this, not all companies do this sensitivity analysis. So it's definitely a value add. And at least I know from my experience, when people see something like this, where you look at worst case, best case for your key assumptions, they're usually pretty impressed, and it makes them a lot more confident in your analysis because they see that you kind of looked at, things that could go wrong. And then if you've done anything about the bad, like negative NPVs that you saw, you have an answer, a comeback saying, hey, we saw this potential negative NPV if sales are really bad, but we've done some homework and we've decided that, if we do a quick survey this weekend, we can tighten our expected case of sales because we'll have more information about the market size. So that usually, brings a lot of confidence to the managers in a business because they feel like you've looked at it from different angles, and they'll probably be more likely to approve a project that you might be working on. So that was sensitivity analysis. Then we looked at scenario analysis. And the difference with scenario analysis is that you're looking at a situation where multiple assumptions change all at the same time. That's scenario analysis. For better or for worse, the only thing I could come up with in my head was a pandemic scenario. And so I asked the question, well, what will happen to this project if we have some type of pandemic? And we said, well, capital investment will probably stay the same, but sales will definitely be a lot lower. Maybe SG&A will be lower because maybe we won't spend as much on sales activities because we're going to be closed down, or we're only going to take online orders. So the point is, in scenario analysis, multiple things change, multiple assumptions, and then you look at this one particular situation to see what happens. And when we did that, we called it the pandemic scenario, we still found a positive NPV of 5226. So that tells you right there, okay, maybe that's not a huge risk that we need to worry about because it looks like the project will still be profitable even if this happens. All right, so that's sensitivity analysis and scenario analysis. I'm going to go ahead and switch us to a couple PowerPoint slides now. All right, let's talk about break-even analysis. If you've done break-even analysis in perhaps accounting, where you calculate a break-even level of profitability or something, or this is popular in entrepreneurship classes, right? Because you want to understand at what point you can break even when you invest in a business. This is done from a standpoint of a project, and it's not about break-even profitability. It's about break-even NPV, net present value. And so what the thought process is behind it is that we're going to determine the level of sales, the sales volume, the level of sales at which NPV goes from negative to positive. So that's kind of like the minimum amount of sales we need in the project for this to be viable. So a couple points here. Variable costs will probably change in our model. And what I mean by that is things like cost of goods sold. So like if we had a pizza restaurant and we had to buy cheese, cheese would probably be a variable cost, kind of a cost of goods sold, and its cost depends on the number of pizzas that we sell, right? So if sales are down, we're going to buy less cheese and we're going to have lower cheese costs. If sales are up, we're going to have to buy more cheese and have higher sales costs. So that's a variable cost. So when we build our models to do this type of analysis, you need to make assumptions that make like the cost of cheese formula that's linked to the total sales. And in that previous spreadsheet, what we did is we assumed that cost of goods sold was a percentage of sales. So for like mozzarella is going to be, I don't know, if they sell one pizza for $15, maybe they have to spend 15% of each pizza's cost on cheese. So they could forecast the cost of mozzarella based on the number of pizzas they sell. We need to do that so that we can automatically kind of go through and do the analyses that we're going to do on the next slide. But there will be some costs that are fixed and they won't change. And so we don't have to worry about linking them to sales. Those will be costs like rent or business license costs, things like that. Costs of furniture or something like that. So the idea behind the break-even analysis is we're going to use all our expected assumptions that we already done, but we're going to vary sales. We're going to keep changing the sales number to see at what point do we get a negative, a zero NPV, our break-even level. So this is the spreadsheet. I'm gonna go back to the spreadsheet we were just using before. And so what we're gonna do is we're gonna change the sales assumption. And the sales assumption is right here. Right now we're expecting 75,000, right? I'm gonna change that sales assumption right there. And then we're gonna look at the NPV down here. And we're going to keep changing the sales here until this NPV down here goes to zero. I'm just going to do it like guess a number and keep guessing and guessing. That's pretty simple. There are some ways you can use Excel solver or I can't remember what that other thing is called, goal seek in Excel. It's a little fancier. Once you program it in, it'll get us a number like in a split second, but I don't think we need that kind of complexity here. So I'd rather just keep it simple. So here I go. Let's try this. So we're at 75,000 now. What happens when we reduce sales down to, let's try 50,000. NPV is 20,000. So that's still positive. Let's go lower. Let's go 25. Whoops. Let's go 25,000. So we got negative 1928. That's a lot closer. So we just have to go up a little again. Let's try 27,000. Oh, that's very close. All right, last guess. I'm feeling lucky, so I'm going to say 27,166. There we go. So that right there, 27,166, that is our break-even level of sales. So how would you use that? You can communicate that to people and say, hey, as long as we hit a sales number of 27,166, we're going to be break even, and we're going to cover all our costs and you know what profits our investors want. We're not going to be making any extra profitability, but at least we're going to cover our minimum that's required. And so then sometimes that's easier for people to decide upon if they know, hey, break even is 27,166. I'm sure we're going to meet that. We're going to break even. So let's go ahead and do the project. So that's the nice thing about this is it makes it easy for people to understand the number and to kind of digest the risk that's involved. Because you see later when we look at some other stuff, you know, with interest rates, and when you tell people the risk is as a measure of standard deviation, you know, they kind of look at you like you're crazy or something, because they don't understand how to apply mathematical concepts like variance or standard deviation with risk. But if you tell them our break-even level of profit of MPV on the project is 27,000 in sales, that's easy to understand. I have a couple extra slides on the presentation. I will just talk about them for about 9 seconds because I made them extra for a reason. I don't think it's the highest priority stuff for us to learn. You can go through the textbook a little bit more if you're curious. I haven't seen too many companies use this. It's when you have a project with what we in finance call a real option. And what it really means is that it means that if you make your investment in your project now, then at some point in the future, you're going to have even more options of whether or not you want to like invest even more for more profits. So it's kind of like a staged investment, and you can invest some now, and you can also decide on based on what happens in the future whether or not you want to invest even more. A popular example for this is like in oil and gas, where you know, companies will pay some money to get some drilling rights, and they will run some experimental drilling core samples and stuff after they've invested in the project, and then they can decide whether or not they want to expand it even further to extract more resources and, you know, warm up the world a little bit more. I'm sorry, that was just a joke. So I'm not going to cover it too much more. It's they have techniques called decision trees, and what I would suggest is take a look at it in the textbook, and if you have any questions about it, how to do the staged real options in NPV analysis, just go ahead and let me know, and we can set some time away on the side to talk about it.